The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
We are shifting gears back away from RCC to conventional concrete, and the committee that I represent here, Committee 330, is the Parking Lots Committee. Okay, the name of our committee is Concrete Parking Lots and Site Paving. So you might ask, what exactly is site paving? As a matter of fact, we've kind of struggled with that question over the years, and one of the some of the original members of 330 have told me that in the beginning site paving was intended to be curb and gutter, sidewalks, the other non-vehicle supporting type pavements that you might see in commercial public places for pedestrian traffic. Over the years that term became more loosely defined, and today perhaps even extended to heavier paving types for non-traditional over-the-road vehicles. So we've kind of come full circle and grown as a group, I should say. The committee was formed in the 1980s, probably the early to mid-1980s. It was a little bit before my time on the committee. And the original mission was to complete essentially a one-stop resource for concrete parking lots. There were a lot of practitioners and industry people that came to form the committee because of the need to develop such a document, because there wasn't a really good comprehensive guide for design and construction of essentially simple, what we think of as simple parking lots. Later there was a companion specification developed, and you see the two core documents there. 330R is the parking lot guide, and 330.1 is the companion specification. These are the dates that the ACI website shows for the publication dates for each of those. I'm thinking that there may have actually been an earlier version of 330R. I can't say for sure, but that was prior to the days of when we had things like electronic versions of documents and so forth. So, and I've since purged my files of outdated stuff. So. Anyway, that's where we are today. There's a picture of the committee's homepage on the right there that shows you a little bit about what we're up to. And you can see that one of our goals and one of our documents under development, which we affectionately refer to as 330X, is the Guide for Design and Construction of Concrete Site Paving for Industrial and Trucking Facilities. So there's the whole story of the site paving thing. We've come full circle. We started this mission because we actually had quite a number of interested stakeholders who came to the committee wanting to develop such a document and join the committee. And I have to say they've been an excellent addition to our group. They had taken this mission to several other committees and had been unfortunately rejected in some cases. The other committees, the related committees that deal with these technologies are 302 and 360, the guys who are tasked with concrete slabs on ground and industrial floor slabs. Also, of course, 325, a concrete paving committee. But maybe because of the site paving thing, or the fact that we had more commonality with this type of facility to a large parking lot, it seemed to be a best fit for 330. Also, 330 only had the two documents working. There were a lot more documents in some of these other committees. So for whatever rationale, we all agreed and welcomed them with open arms, and we proceeded to get started on this. Our Robert Varner is in the back of the room. He's our current chair of 330, and I'm glad he's here to help bail me out. I was the chair prior to Robert. I think Robert's kind of on the tail end of a 6-year stint. I was chair for 6 years prior to Robert. And I was chair when this group first came to the committee wanting to develop this document. In the time frame 2004 to 2005, I went back and looked at our committee minutes, and the first mention of developing the document was in the spring of 2005, and we very quickly got started. So you can say we've been working on this for 10 years. I can tell you with great confidence that give us about another 10 years and we will have this in print for you to use in the field. Hopefully a shorter period of time than that. We actually think we're pretty close as we speak. In order to understand why we really needed to do this, it's probably a good exercise to take a quick look at the committee's core documents and what they were intended to do, and how perhaps they don't cover this type of a pavement design and construction challenge. The original intent of the committee was to provide a very general, very broad guide for design and construction of common parking lots of all kinds. And it should be noted that industrial and trucking facility pavements that carry very heavy loads, and lots of them, are really quite different and more complex than what was intended here. Nonetheless, the 330 guide did have in the design tables accommodations for average daily truck traffic up to 700 trucks per day. This sounds like a at least a borderline industrial pavement. More on that in just a minute. But it was really true, I think, that the original 330R design guide was never intended to cover heavy industrial type pavements. And so we had this situation that we really needed some help with, and the new guide seemed to be the thing that we needed to do. And the group that came to us wanting to develop this document were quick to point out that there was no such document that existed to serve this facet of the industry, and so this guide was badly needed. In order to understand the distinctions, it's probably good to take a quick look at what the original 330R guide was all about and what it exists to do today. It is focused on common commercial and public parking lots. The design tables do contain traffic assortments of average daily truck traffic up to 700 vehicles. That's true, but that's a little misleading, because when you really dig down into the design process and how the tables were prepared, that average daily truck traffic is as would be reflected by a traffic counter at the entrance. In other words, no individual square foot of pavement in that entrance or anywhere on the facility sees more than half that volume of trucks. Okay, so you're really talking about at the most 350 loadings, and those are axle load distributions that assume in general a broad range of configurations and ultimate loads that are generally, on average, lighter than fully loaded over-the-road vehicles. The thickness tables, and we'll take a look at the table in just a minute, cover a broad range of soil support values, concrete strengths, and truck traffic volumes. Load transfer dowels, load stability design, was not an important focus of this document, quite contrary to industrial and trucking facility type designs. And in general, these load transfer dowels were not only not emphasized, you could almost read between the lines that they were being discouraged in the guide. There were alternatives to load transfer dowel design in the guide. And likewise, the use of subbases was essentially discouraged except in special cases. Again, somewhat different than for heavy industrial type pavements. That's what the 330R thickness table looks like. You can see the range of traffic from 1 truck per day all the way to 700 trucks per day in 4 different traffic categories, which range in percentage of heavier type truckloads from very, very light to, in the D case, essentially 80,000 pound trucks. The other things worth taking a quick look at here are that there are 6 different areas of the table, and the K values that reflect the subgrade support conditions that are included in this guide range from very high, which would be a cement treated base type application, to very low. 50 psi per inch is a very, very low caliber supporting material, something that would not be usually considered appropriate without considerable improvement for a trucking or industrial facility. Also, the concrete strengths are fairly mild, ranging in third point modulus of rupture from 500 to 650. Again, probably a little bit different would be what we would consider appropriate for industrial and trucking facilities. So here's some things that would distinguish the new guide from the existing parking lot guide. One is that in addition to regular over-the-road vehicles and trucks, wheeled vehicles that are legal on the highway, these industrial facilities and even some trucking facilities have a number of other design challenges, loading challenges. Point loads like dolly stands, when you unhook a trailer that might still be loaded, the wheels or the dolly pads on that trailer have some pretty significant point loads. And in some cases, there might even be the feed of rack storage equipment and things like that, other types of product storage on the site. Then I mentioned the subgrade and subbase issues. The norm for the rule rather than exception for such very high volume, high loading traffic would be higher supporting values in the composite section of the subgrade, often improved subgrades, and subbase layers, specially constructed. Joint stability, that is load transfer devices, are a much more important, integrally important part of the design and the construction details for these type of facilities. We usually have a little bit higher performance concrete mixes in the design process, and there's certainly larger areas in general, and we often encounter different placement methods than might typically be covered in a parking lot document. There's also some fairly new technologies that are being brought into this type of construction that needed to be covered in this document. For example, we're seeing lots of these facilities today that are built with somewhat higher slump concrete than might be a traditional, say, a slip form or a vibrating screed type placement, using laser screeds. And often the same contractor and crews that might be doing the building slabs are actually doing the exterior paving as well. So that's something that needs to be considered. There's new load transfer technologies, which has been something of great interest to the group. A lot of these trends have been brought to us with our new partners from 302 and 360 and other committees where there's a lot of expertise. We've really got a pretty powerful team in place now, I think, that has a lot of expertise from a variety of different segments of the industry. So a lot of consulting designers, specifiers, academia, as well as some pretty high-powered contractors, very experienced in these type applications. So we've got a pretty good team in place for this, and we're actually corresponding very closely with some other important committees, 302 and 360, and other committees as we work through some of the issues. There are some trends for, I mentioned the non-standard wheel and point load type conditions and the subgrade improvement issues, and how you characterize the support to the slab when you have an improved subgrade and a constructed subbase over the subgrade. So I thought maybe the best way to give you just a real general feel for what this document is going to, in likelihood, look like is just to take you through a quick overview with some examples of particularly some of the design tables that appear in the draft. And I realize this is a draft, and it's still subject to some additional review. We have been through the TAC process once. We've balloted some but not all of the responses to that TAC review process. So there are still changes that are in the works here, but this is a real rough feel for some of the design guidance. First, the general distinctions relative to the old 330R parking lot guide. First of all, we're talking about design loads that are 100% of the design traffic is in the design lane. So quite contrary to the ADTT concept, 100% of the design loads are in the traffic lane. And we're designing the pavement, we're checking to see what controls, whether it's over-the-road vehicles, whether it's non-standard vehicles like lift trucks that are maybe considerably above legal road limits, and different types of wheel configurations, and of course point loads and storage loads and things like that. We've got a much higher focus on the non-eroding subgrade materials and the subbase layers that are constructed that work together with them, have much more stringent requirements for joint spacing, joint details, sealing of joints. I mentioned the joint stability and the load transfer design at joints. Control of pumping and subgrade erosion is a very important part of that design, which is, and there's a lot of specific guidance on load transfer devices in the draft of the new document. And we're talking about more concrete mixture design information focusing on durability, low shrinkage rates, and those kinds of things. And also optimum properties based on different types of placement scenarios and different equipment than you might see used on many common parking lots. More detailed construction guidance, a lot of different options on placement and finishing. Here's what the contents in the draft look like. It's a pretty sizable document at this point. The chapters include all the stuff that you would imagine that they would. A lot of inspection and testing information, very important parts. Also some maintenance, preservation, and repair. I'm talking, of course, in addition to the stuff about subgrades and subbases, the design process, all things to consider, the materials, the construction process. We have the sustainability chapter that's featured in most ACI documents going forward. And in the appendix, we got some really useful stuff, too. A lot of more soils classification information and how to use that. Some information about the different design software that has been employed and is available, as well as a pretty significant design example. We have one appendix section on the enhanced aggregate interlock method of light gauge reinforcement through joints in order to provide an enhanced aggregate interlock that will not, a joint that won't open as much with that light gauge reinforcement, a different design scenario. And then a good bit about curling and warping and how it relates to shrinkage and the other related factors there. Just a few examples, and here again, realize that these may still change, of some of the tables that are used in the draft to aid the designer. First of all, there's a lot of information, good information about better characterizing improved subgrades and subbases, and we rely on the subbase resilient modulus for characterizing the different types of materials and how we're going to figure a support value for the composite subgrade subbase system. Some ways of estimating some of these factors if they're not known. And here's some of the different categories for different ranges of modulus of rupture in the subbase material, the different thicknesses, and what the resulting layer K value would be. Here's a thickness design table for over-the-road vehicles. And it's kind of interesting to note that everything here is on a higher level than in the 330R parking lot guide, as you would imagine. First of all, the traffic assortment is much heavier. A fair percentage of the assumed traffic distribution in that loading is vehicles heavier than what would be characterized by typical axle loadings of an 80,000-pound over-the-road vehicle. So that's pretty significant. Also, it's worth noting that the modulus of rupture of the concrete is in a higher range. It actually goes from, instead of from capping out around 650, it now goes to 750. Also, the K values that are assumed for the subgrade subbase system don't go below 150 and are typically in the 150, 200, and 300 categories here. So 1,000 trucks per day, maximum traffic, and that is essentially compared to distinguished from the ADTT, because that assumes that the area of pavement that you're designing sees all 1,000 of those trucks. Then we have table resources for lift trucks, a variety of different kinds of lift trucks. There's a couple of tables, one for lift trucks that have single wheels on the axle and another for dual wheels. This is the one for dual wheels, but you can see the size of these, the loads get pretty significant. Axle loads all the way up to 150,000 pounds. Different contact areas and tire pressures, all the different assorted modulus of rupture and subgrade reactions, and the thicknesses that would control for these vehicle loads. Then we have the punching shear and punching shear stress part of the dolly wheels and dolly pad loads, point loads that are sometimes pretty severe on the pavement for both punching shear as well as bearing stress. Both of those have to be evaluated, and both are being covered. Then finally, there's quite a bit of additional design information on the load transfer devices. There are a lot more options than we used to have in load transfer devices, including not only the traditional round dowels, but square dowels and plate dowels, which are featured here with specific design guidance. And this is a work in progress too, but there's a lot more guidance here, specific design guidance in load transfer design here. And there are quite a number of recommended details for the pavement sections and systems that are more significant than typical parking lot type concrete details. This is just an example of some of them. Finally, we've addressed the question of which document do I use if I've got a facility that may be kind of in between a normal parking lot and a distribution terminal or something like that. Which guide is appropriate? So we tried to address that and given some not only general guidance but actually examples of each type of facility to help the user choose which document will be appropriate to go to for his design. And there will be some overlap. And I should say that we've already discussed in committee the fact that our 330R parking lot guide in its next revision will probably be dumbed down a little bit with lower levels of traffic and design extreme levels in order to better distinguish the two. So with that, if there are any questions, I'll refer them to my driver in the back. Or
please, are there any questions for Tim?
Just want to get up. Are we doing anything about the expansion joint questions that we see so many times in these large facilities? Is ACI taking a position on the use of expansion joints in those pavements? Like redwood, yellow pine, or whatever?
Well, you know, load transfer being an important question, I'm not sure Robert, what do we talk about material-wise in those types of joints? Isolation joint versus expansion joint, those kinds of questions?
Well, we talk about isolation and expansion.
Yeah.
Are you talking about the material?
Yeah, in Texas is common practice to put in 1/2 inch or 3/4 inch redwood or treated pine or something in there every 100, 125 feet.
I don't think we recommend that.
Good. Well,
No.
I think the document needs to have a statement along
Yeah.
those lines because we have way too many civil and geotechnical consultants still putting that in, which becomes our major area of repair on these facilities.
I can
love the isolation,
yeah.
isolate it from the structural elements, but get rid of those.
We actually cover that in 330R as well with the same recommendation. We don't recommend interrupting the normal joining system in either direction with a compressible joint of any kind because it leads to all kinds of deterioration.
And we are talking for the most part about unreinforced concrete here. You know, in Texas, you're going to have, you know, the reinforcing. You're going to have. You're essentially talking about jointed reinforced concrete, and this will hopefully be a step to show consultants that's an antiquated system.
I don't know that we
It goes
specifically mentioned redwood anywhere in the document. And it may be that an Appendix E on the Texas system might be worthwhile considering.
Yeah. Other questions or comments? If not, Tim, thank you very much. Appreciate it. And for all our speakers, and thank you for the audience, too.